Hello everyone, in this video we're going to talk about paired t-test. It's a type of hypothesis testing to analyze two populations and compare them. When these two populations of interest are collected in pairs, and that's when we're doing the paired t-test. It's to analyze the differences between two populations, but when they're collected in pairs. One example is cancer patients' tumor size before and after treatment. Here, the patients are the same patients, essentially. And that makes it a paired data. The subjects that we collected data from are the same subjects. And the assumptions behind this type of test is that two populations are positively correlated if data is paired, and the differences observed in pair of data are IID normal random variables, independent and identically distributed. So the way that we collected data is shown here. So here we have n pairs of data. So this is the first pair. Let's say patient number 1, before the test, after the treatment, basically. Patient number 2, before the treatment, after the treatment. And you collect these n pairs of data, and then for each pair, you compute the differences. Basically this one minus this one. And then you have a new data set of d sub I. And this d sub I will be the focus of our test, because we're going to look at the differences in these data that we collected. And then the DI is assumed to be normally distributed with this mean, which is essentially the mean of 1 minus mean of 2, before and after. The average of before minus the average of after. And then we formulate our hypothesis test on the mu of D, mu of differences, average of differences. And then we have to make a decision about delta naught, typically 0. We talked about that. This is typically 0, indicating that we're looking at whether there is any difference. But keep that in mind that the test can be one-sided. This is a two-sided test, but it can be a one-sided test when you have a less than or more than in the alternative hypothesis. The point estimates that we're using here are d bar. This is the sample average of differences and standard deviation of differences. And these two point estimates will be used to calculate the test statistic. The test statistic is T naught, and here you can see that you have d bar, you have the delta naught, which is typically 0, standard deviation of differences, and the sample size, how many pairs of data essentially. And then you compare the test stat with the critical region. You're probably familiar with these critical regions by now. For a two-sided test or one-sided test, you have different critical regions. You can also do the test looking at the p-value. These are p-value formulas, where you calculate, for example, here 2 times probability of t with n minus degree of freedom greater than absolute value of t score. Or you can calculate the confidence interval as well. For a two-sided confidence interval, here you have the lower confidence limit and you have the upper confidence limit. And this is useful when your alternative hypothesis is mu of d, mu of differences, is not equal to some delta naught. And also you can calculate the upper confidence interval only for one-sided test when your alternative hypothesis is mu of differences is less than delta naught. You only calculate the upper confidence limit. Or you calculate the lower confidence limit when the alternative hypothesis is mu of d greater than delta naught. And in all these calculations, you see that d bar and standard deviation of d, these are critical parameters, and these can be calculated from the sample data that you collect. In the next video, we're going to look at one example to make all of these more clear.